All right, welcome back, and we have the D1 in question. This is the one that was on the left of the video that I posted about the storage tube question. So this is the unit with the storage tube that is not working. So we'll get this one all tuned up. I have another video that has a non-D1. It's a much older unit that needed repaired. We'll get into it. It's a curve tracer with a storage tube, so let's get started. Okay, in the previous video, which is actually uploading to YouTube right now, the curve tracer gave me some trouble in the alignment, and I want to show you guys what is going on, and we're going to correct that in this video and show you guys how to fix that, because it gave me some trouble, but I did manage to nail it down. Okay, so there's the spot. Okay, so the test that we do is you line up the dot in the center when it's on AC, so the settings are 6.5 volts, highest resistance, step offset doesn't matter, but 200 volts per collector and 2 amps on the vertical, so you essentially tune it to its lowest intensity. And then if I go to positive or NPN transistor, it should come down here and be close, which it is. We'll line it up in the corner, and then if I switch it up to negative, it'll come up here and be close, which it is. But then what you do is you hit invert, and it should go back down to the lower corner down here. So you hit invert, and mine jumps up here. That is not a problem with the frame. That is actually a problem with the 177's calibration. So this needs to be adjusted. There's 2 adjustment points on the bottom of this, and that drove me nuts with that really early unit. So this is what needs a the DC balance adjustment is the one that's causing that problem. So I will get into this, and I got to calibrate the 177 before we do the curve tracer frame, because that's going to throw off the curve tracer. So we'll do this guy. We'll do this first, then we'll do the curve tracer. So I will get the 177's manual out, and I will show you guys how to do that. Okay, before I did anything with the calibration, I did want to check the plus 30, minus 30 volt power rails, and it does turn out those were out of spec. So I did adjust those, which does mean we're going to need to do a full recal of the instrument because the power supply rails were toast. So I'm in for a full cal, but that was to be expected anyway. They're in spec now, 30.001. And then 30.002. So they are within 0.5% of rated voltage, and they are within 0.5% of each other, which is necessary for the 577s. So I can move on to popping the base off of the 177 and get that calibration started. So I'll get everything rearranged, and then I'll be back. Okay, to do a 177 properly, the unit does need to be on its side. There's a plug you need to remove in this hole, and then we have 3 adjustment points. So not much to do on a 177, but very important because it'll throw off the calibration for the rest of the unit. So let me get the service manual, and we'll get to it. Okay, so with the curve tracer on its side, spot is centered, and we want no movement of the spot, or no vertical spot movement for when you switch it between 100 milliamps and 50 milliamps. Obviously we have lots of spot movement, so first adjustment is R610. And you do want to use insulated tuning tools for this adjustment, because there's high voltage all over the bottom of this thing. Okay, brighten this up so you guys can see. That was a little fiddly, but as you can hear, no spot movement between 50 and 1, so that one's done. Alright, well, we have our first troubleshooting snafu. I did finally get the reading of 0.4 millivolts. The main problem is I did not get it out of the 177 that I was trying to use. So, where I was having problems was I did not have the base connected to the step generator. This was set to base grounded, so that's why I was getting no voltage out, so that makes a lot more sense now. So I need to, that did not affect the vertical preamplifier though, so we don't need to redo that. It did affect this one, so now I need to do, this is vertical gain. We have 0.4 volts, 400 millivolts on the curve tracer, or on the DMM. I need to move that to one of the pins on the inside of the collector supply. I'm going to move the camera because there's all kinds of crazy dangerous voltages running around in there. So I will do that, and then I will be right back. And we are off a little bit. This adjustment is okay. On this one, the common mode rejection ratio, I've got everything all hooked up. The common mode rejection ratio, there is minimal deflection, so all is good. Don't need to adjust that one. So my common mode rejection ratio was very, very off. I'll show you guys what this looks like here in a second, once the tube warms up. So this is a control that can invert, flip back and forth. You want to set it for minimum deflection. So that's it right there. So if you do the common mode rejection ratio, if you do R617, you will need to redo step 1 and 2. I will redo step 1 and 2. I'm not going to bore you guys with that, so I'll get those done and then I'll be back. Okay, I'm doing the last little bit of the looping compensation capacitor. There's just a tiny bit of tilt that I need to get rid of, so do that real quick, and then that will finish up the 177. So we'll be right back, because this there's a lot of stuff that can be easily damaged around that cap, so I got to get a light in there, see what I'm doing. So I'm going to move the camera. When I get that done, I'll be right back. That looks good right there. So that concludes the calibration of the 177. I'll put the lid back on, and then I can get started in doing the D1. Okay, so where we're at. I have finished the 171 alignment. I let the power supply burn in for an entire evening just to make sure it was okay. All the supplies regulated properly, so that was all said and good. We've already adjusted the negative 30 and negative 50 volt supply, so we are on to the negative 3,400 volt supply for the intensity. Let me turn this off real quick. Yeah, it's off. Unplug this. Okay, I just wanted to set up the front end, 6.5, 0.5 watts max peak power, variable collector 0, and that's good for the adjustment, and intensity and brightness are completely off. So that's what we need for the adjustment. So let me spin this back around, get the probes hooked up, and then we'll turn it on and let it warm up for a minute. Okay, unit's back around. On the 577s in particular, the negative high voltage is taken off of the back pin. As you can see, the unit is unplugged. It has been off for a while. I haven't even plugged it back in since I spun it around. So it's pin 1, pin 2. So we hook all this stuff up while it is off and unplugged because of the high voltage. So we'll plug this back in, then power on. And I am supposed to have approximately 3,400 volts. Anything from 3230 to 3570 is fine. My meter is telling me we are at 3,433. So that is well in spec. But since we're doing a complete calibration, we can adjust it. Now, when doing these adjustments, use extreme caution. You do have negative 3,000 volts exposed on the bench. Well, when we're dealing with 4 kV, plus minus 2 volts is good enough for our lab. Okay, I'm gonna turn the unit off, button everything back up, and then cover up the high voltage again and make it safe, and then flip it around, and we'll continue on with the calibration. Okay, so adjustment on here is check for intensity. Yes, we can get a spot. Turn that completely off. Now we need to adjust our 1245 until a faint spot is visible. Use a insulated screwdriver. This is in the high voltage supply. One sec. Intensity is all the way down. Yep, we can get a spot. There we go. Okay, so we have a faint spot is visible. And then you turn the intensity 1 panel mark. Zoom in on this so you guys can see it. So with it all the way off, there it is. So we turn the intensity 1 panel mark, and then we adjust this. Just so the spot disappears. I'm actually going to remove this cover real quick to do this, because this green filter actually absorbs quite a bit of the light, and I would rather have more control on the intensity control. So we'll pull the green off. Faint spot. Rotate the intensity control. Oh, okay. No, sorry, I messed that up. So you want to, so we have the spot, so we need to turn the intensity control slowly. right there. So that's about at the 9 o'clock position of the intensity control. Right there. And so, because the effect you're looking for is just till it starts to brighten up. Right there. See how it's just brightening up? So now we want 30 degrees past that, which would be the tick mark right over the 9 o'clock, so 10 o'clock. Now we want to back off okay. So spot disappeared. Intensity control is set right. Get the cover put back on and get set up for the next one. Okay, so now we're into astigmatism and trace rotation. So focus control counterclockwise, intensity completely clockwise. Do this fast because you have a very high intensity spot and you're just looking for a round spot because it can go oval. Just looking for round. Our rotation's off a bit, so it's 0.5 volts on the horizontal and then just 10 divisions of display. But we need to adjust the trace rotation pot. You just adjust the trace rotation pot for flat display. Now we're going to check the geometry. Actually, the geometry looks really good. You just look for 0.1 division or less of bowing. Do the same at the top. Yeah, it's okay. A little bowed at the top, but it's not bad. Go to center. And then we short collector and emitter. And that's actually a little off, so we do need to adjust the geometry just a bit. Okay, I need to fiddle with this one, so I'm gonna move the camera out of the way, and I'll be back. Okay, got the adjustment done. Just to show you guys, if you watch the trace move, focus. Come on, there we go. So if you watch the trace move, there's minimal bowing, and it's even bowing across the whole display. Okay, next up is the storage adjustments. As this is a D1, we do have to do the storage adjustments on this one. Really the only difference between a D2 and a D1 is this board right here, which is the storage board, and the tube itself. So this is just the different style of amplifier for the newer model of the newer serial numbers of the D1. So this is the storage board. Right in here, that's where all our measurement points are. So the way these measurements are taken is the 370 volt supply is referenced to ground. Everything else is referenced to flood gun cathodes, which is pin 3. So I will get the meter set up and we'll do those adjustments here real quick. I did take the adjustments down from the other D1 that I have that's working correctly. Now one of the things is if you got one of these tubes from Tektronix, they would have come with a card brand new in the box. They would have come with a card that told you exactly what to set these voltages to, because Tech evaluated them at the factory. Obviously, they're not making these anymore, so those cards are long gone. However, with pin 3 reference to ground, pin 1 was 113 volts, pin 2 was 353.1 volts, pin 4 was 115.9 volts. That's referenced the D1 that I have that was functioning normally in the other video. And for reference, I counted the pins left to right, so 1, 2, 3, 4. And the conditions were brightness for the storage was in, target was erased, brightness was 100%, pin 3 is ground for all measurements. So that's the way I set these up to take those readings. But let me get some probes and we will get started on these. Okay, the readings for this are grounds being picked up right here. Set to test point 2. We need to adjust for 370 volts. Now, just in all the measurements that I mentioned earlier, all of those were taken on the Keithley DMM 6500, so the 6.5 digit, and it's the most accurate meter I have in the lab. So that's what I used for those, which is the same meter I'm using here. So we're going to adjust right here. We're going to push storage buttons in. There's 370 volts. And we're good for plus minus 7 volts. We're at 370.1. So we are good there. So now all the other measurements, I have to move my ground to test point 3, because that's where the cathodes are for the flood guns. Well, I just gave you guys some bad information that I just figured it out. Pin 3 on P389 is actually right here. So I will see if they have continuity between the two. They might be the same, I don't know, but I'm going to check that here right now. Those are not the same point in the circuit as pin 3 down here. So all of this, so we'll do this from scratch on this tube, since we know this was the tube that was driven hard, so you guys will see the adjustment from scratch. This is the pin 3 you want, not pin 3 down here. Sorry about that. Okay, so to check the target, you turn up the intensity so the trace defocuses rapidly. In this case, it's the 1 o'clock position, and then you move it vertically. So if I store this, move it vertically, so that's not broken, so that's good. But if it moves faster, this is what you're looking for. You don't want anything breaking like that. So because no breaks were evident, we're going to drop the store level by 5 volts. So we're going to go back to 200. Turn up the intensity to the same point again. Turn this down. Now I'm just waiting to see if any lines develop. No lines developed. It's 10 seconds each time, so no lines developed. So we'll erase the target and drop it another 5 volts. Erase the target. Turn up the intensity again. That still looks good, so I'm going to come down a little bit more. This spot is actually a spot of burn on the screen, so that's nothing to worry about. Okay, that looks good, so we're going to pull it down even more. Pulled it way down that time, but this is now looking a lot more healthy for a storage tube. It's not overly bright and blasting me in the face. Still trying to find the minimum writing rate of this tube. This still looks good. This was way out of adjustment. I'm starting to get some right here. Okay, we're starting to lose some. We're starting to lose some breaks and gaps. So now we're a little low. So what we'll do is I'll bump it up by 5. Now I have to wait 10 seconds. Turn the intensity up. Turn the intensity down. Okay, I am losing a little bit at the bottom here. It's not holding the storage, so I am going to bump it up another 5 volts. So let me do that real quick. Okay, so I'm going to call for this tube. The minimum writing rate is going to be 166. Now we're going to look for the maximum writing rate, but this time we're looking for background fade up. So since we know this tube was very overdriven, what I'm going to do is I'm going to bump it, let's call it 180, because we're starting at 166. Actually, we'll do 190. Okay, we're having background fade up there, so we need to come back down. Still having background fade up. Touch of background fade up. So what I'm going to do is I'm actually going to come down to there. Yeah, that looks good. I'm not getting any background fade up, so that looks healthy. So what that means is max for this tube is 171. So what they want us to do is, should be right in between the two, is where it wants us to set the voltage. They want, this tube wants 168.5. We can give it that. Okay, there we go. So, here's where we were beforehand. Initially, we were at 206.5 volts. Minimum rating was 166.0. Max was 171. So, the ideal adjustment was 168.5. So, this was way off. Alright, so now we need to do the culmination. Due to, we had a significant adjustment of store level, so the culmination is definitely going to need to be adjusted. So I will get that set up, and then I will be back. Okay, I've gotten the calibration done on this particular curve tracer on the D1. So I'm just going to check that. We have a 200 ohm resistor that checked at 200.033. So I'm going to wind this up. My settings are 20 milliamps per division on the vertical, 5 volts per division on the horizontal. So 5 volts, 10 volts, 15 volts, 20 volts. And with a current on 20 milliamps a division, 200 ohm resistor, 20 volts, we should have 1 amp, 20, 40, 60, 80, 1. It is exactly where it should be, so we are right on the money on this one. I will get, let's see, what else do we have? Okay, here's another test. We're at 0.1, so we're at 100 millivolts per division this way. So we have a total of 1 volt. I have it set to 0.2 amps a division. So we should end up right up here. So I've switched out to a 1 ohm resistor. So at 1 volt, we should have 1 amp. So there's a volt, 2 volts, or, sorry, 0.2, 0.4, 0.6, 0.8, and there's a volt. I'll turn the brightness up for you guys. So shift this just this way, get the glare off the light. So 1 volt into 1 ohm gives us 1 amps. So we are bang on. I'll do some more checking on this, but this is working really, really well. Looks like the calibration took. Okay, the one thing that I wanted to show is the test. To see if amplifiers are in spec and ready to go. So if I set this to AC and we center this, so you want the dot exactly centered with AC. If I go to NPN, which is not DC plus, it's just plus, you should be within 0.1 divisions of down here. You should then be able to flip it, and you should be within 0.1 divisions of this top corner. You should then be able to hit invert, and you should be within 0.1 divisions of this corner. If that doesn't happen, your unit is out of spec. It needs to be adjusted. I ran into that problem And this was the rabbit hole that I dove down on that older unit. I even thought the older unit was going bad, just well out of spec given the age. But what it turned out was there's op amps in the 177 that have to be adjusted first. If the 177 is not in spec, specifically the amplifier balance, if that's not in spec, that test that I did will never work right. On this unit, when I started before I did the 177, it was 3.5 divisions up. So it was up here. So if you're going to work on these, if you're going to do one of these, one, if you're following along, you're doing so at your own risk. 2 is make absolutely sure the 177 is done before you try to do the unit. Drove me nuts in the last one. That other unit, which I posted the part 1 on, that is in process. I do have the parts coming for it. There will be a part 2 where we finish that one up. I do want to finish that one just for preservation's sake because it is serial number 124, so it's a very, very early production unit. So I do want to preserve that. One of the reasons for getting this up and running is I'm going to turn the brightness up. The storage tube is in spec and everything is working. I can go ahead and erase this. There it goes. So we have the storage tube back up and running. So everything is good on this one. Thanks for everybody who weighed in on this, on the questions video. This was definitely out of spec. Quite a bit, actually. Don't know what happened to it before me, but somebody had fun. Thanks for stopping by today, taking a look at the Tektronix D1 storage curve tracer. There is no pile of carnage for this one, because this one actually didn't need any spare parts. It was just very far out of adjustment. So, got everything all squared away. I will go into the 177 a bit more in part 2 of the older D2 and get that working. And then I got a lot of other stuff planned for the bench. So, as always, I do check all the comments. So if you guys have anything for me, let me know. And I will see you guys in the next video.